In our last video, we explored the so-called powerful geothermal engine operating deep underground, which is a high-pressure system of hot rock and trapped water. Continuing this engine analogy, this raises a critical question. If this engine is hidden miles beneath our feet, then how do we even know where to look for it? Well, just like a pressure cooker on a stove, even the best natural system isn't perfectly sealed. The immense pressure and heat find ways to escape to the surface through cracks and fissures in the rock. These leaks are what we call surface manifestations, and they are clues that tell us exactly where a reservoir is below. The most common clue is a hot spring. This is where geothermally heated groundwater flows gently to the surface. The vibrant colors you often see are from different types of heat-loving bacteria called thermophiles. But for a geoscientist, the water itself is a message from below. By analyzing the dissolved minerals like silica and chloride, we can use established geochemical formulas to estimate the temperature of the deep reservoir the water came from. It's like taking the temperature of an engine without ever touching it. If you see steam hissing out of the ground, you're looking at a fumarole. Think of this as the pressure release valve on our underground cooker. It tells us that the water in the reservoir below is so hot that it's boiling and turning directly into steam. The distinct rotten egg smell often present is from hydrogen sulfide gas, which, along with carbon dioxide, are primary gases released from magma. So ephemeral doesn't just tell us it's hot, it strongly suggests a magmatic heat source is fueling the system. Things get even more interesting with mudpots. This happens when you have a lot of steam and gas, like hydrogen sulfide, rising through an area with very little groundwater. The gas mixes with the water to form sulfuric acid. This potent acid dissolves the surrounding surface rock, turning it into a bubbly, goopy stew of clay. A mud pot is a clear sign of a very active, high temperature and acidic system at work. And finally, the most spectacular clue of all, a geyser. A geyser is a hot spring with a very specific type of underground plumbing, which is a series of constrictions and chambers. Water fills the system, is superheated by the hot rock, and builds immense pressure. Eventually, a small amount of water flashes into steam, which rapidly expands and violently pushes the entire column of water above it into the air. The fact that it can repeat this cycle tells us the system is not only hot and pressurized, but is also being actively recharged with new water. This is undeniable proof of a powerful and dynamic hydrothermal system. Even when the water is gone, the evidence can remain for thousands of years. As hot, mineral-rich water from hot springs and geysers flows over the surface, it cools and deposits its dissolved minerals. Silica-rich deposits are called sinter, while calcium carbonate deposits form travertine. These beautiful layered terraces are the solid footprint of a geothermal system, telling us that the area has been geothermally active for a very long time. So, from a gentle hot spring to the solid terraces left behind, these surface manifestations are the Earth's natural billboards. They are the X that marks a spot for geologists and engineers, providing critical clues about the temperature, chemistry, and power of the hidden engine below. By learning to read these signs, we can turn a visual wonder into a source of clean, reliable power. Next up, we'll explore how we can take advantage of the hot rock anywhere through the revolutionary technology that has enhanced geothermal systems.